Hi, this is Dr. Tom Kessler. Welcome. This is the first lecture in a series of lectures that I've prepared having to do with the use of statistics and statistical methods. The important thing to understand is that statistics are a tool set, just like hammers and screwdrivers and pliers are tool sets. And when you have a tool set, the important thing to do is to learn what's in the tool set and to learn how to use it. And so in this lecture and the ones that follow, that's going to be what we try to do. Appreciate that statistics are a very powerful set of tools, and they're used by many people and many organizations for many purposes. They're used in the government and the private sector, by administrators and analysts and researchers, and they're used, different statistical methods are used to analyze a pile of data, conditions, relationships between different pieces of data, and statistics are used once you analyze data using statistics to make decisions. They're important to graduate students for sure, because in many of your graduate classes, you're asked to analyze data, to investigate relationships, to examine what's causing a certain condition, and to make recommendations to decision makers. So that's important to understand. Also, it's important to accept the fact that some who take graduate courses that have to do with statistics are afraid of statistics. And I always blame the school system that we all came through. I'm a product of a public school system, the Baltimore City public school system. And I have to say that my math teachers did not really teach me at first why do you need to use math and then how to use it. They just taught me how to use math. And I struggled with to get through tests. And if you're in that category, you may have grown up with saying to family and friends, you know, I don't like math, or I'm not good at math, and the same thing might be true about statistics. And so, you know, again, I blame the way we were raised, and I think as a result of how we were introduced to math and statistics, we were confused a bit, and we tuned out. And so I generally say that if you're a parent and you have a child in the 6th or 7th or 8th grades, you, the parent, should be working with them to understand math and statistics, especially statistics. You know, you could say to them, you know, all right, look, we're going to sit down here and figure out if there's a relationship or a correlation between the grades that you're getting in school and how much allowance you get, and then gather data and analyze that particular question. And if young people learn at a reasonably young age, just like learning a foreign language, how to use the tools, then I think there's a strong appreciation as they grow that they can answer a lot of questions using statistics. Statistical concepts really do embody some very powerful capabilities. But first, in order to really get into the tools and using the tools, we have to figure out our point of view. For you, in your early parts of your statistics classes, you're probably going to be given a pile of data, a set of data, and you're going to be asked to do things with it, to analyze and understand and see what you can learn about the data. You may, in other cases, start with no data. You may have a problem that you want to analyze. You may have to figure out what data you need to collect in order to analyze it. You may have to then collect that data, typically using a survey or interviews, or doing what's called a record study, looking at maybe patient records or student records or whatever. And then when you collect that data, you put it into an Excel spreadsheet or something similar, And once you have the data collected and you have it in the spreadsheet, you're then ready to start where I mentioned a minute ago. You probably could start, and we'll start in the classes where someone gives you a set of data. So the concept of collecting the data and designing data collection instruments is really called research methods. And we're not going to do that in the statistics discussion. We're going to assume that there's a set of data that we need to analyze. Because in order to use statistics, you have to have a set prepared and ready to be analyzed. So we're going to start from that perspective. So collecting and organizing data is important. But once the data is there, you have to observe the factual characteristics about that data. So here's 10,000 records about car purchases over the last 2 years. And that's all I know. It's 10,000 records about car purchases. Well, what can I learn by examining that data? And we start with small things. Let's just look at the characteristics of that data. Let's see what the characteristics can describe or tell us. And so we'll start with descriptive statistics. And then once we dig and we sort of see this data set and we're able to start to understand its characteristics, its descriptive characteristics, then we can start to do other things with the data. We can say, well, let's pose some questions about the data. Like were younger people, maybe those under the age of 40, more likely to buy a sports car? And we can start to pose questions and do other things. But let's just start with the easy things by taking a set of data and examining that set of data and seeing what we can tell about it. And that's what this lecture is about. So we identify the nature and strengths of relationships among data attributes in the sort of the more advanced part. But first we start by looking at the descriptive characteristics. And you see some questions on this slide. Some of the more advanced questions, like, what's the relationship between vitamin taking and health? How does minimum wage increase affect the price of goods sold? So those are more advanced questions. Those are the questions we ask in another lecture, where we say we'd like to study the relationships among some of these variables in this data. In order to take advantage of benefits, you first have to understand some basic concepts about data, and that's what we're going to do. So this is my picture, my image, my global map. I always tell my employees and I tell students that I like to see a one-page picture of the whole thing. And so this is the whole thing. This is all of statistics, right? This is, understanding the purpose of statistics, understanding some concepts about statistics, data concepts, how to structure a problem. What are descriptive statistics? These are the parts that we're just looking through the data to see what it tells us. And then the inferential statistics, where we're sort of trying to compare data elements to answer questions. Also, there's the research process that I alluded to, and that is to plan your analysis, collect your data, and input your data. That's part of research, and we're not going to do much of that. Then there's the process of data, which is what happens with descriptive and inferential statistics. You get some output, and you have to interpret and conclude based on the output what you're seeing. And I have a lot of lectures to really help you with that last part especially. And then we have tools to enable this to happen. We're going to be using, for my lectures, Excel. And we're going to put the data into an Excel spreadsheet. Now, Excel does have some statistical capabilities, but I will tell you that they're quite constrained and not robust. That's the way I have to say it. And so we're also going to need a more powerful package sitting on top of Excel, used with Excel. And I generally lecture from a textbook that comes with a free student edition of a product called Palisade Stat Tools, Palisade Decision Tools, and one of Palisade's tools is called Stat Tools. So I'll be using that quite a bit. SPSS is another statistical package you could use, depending on which university you're at. You may have free access to that from the university if we're checking. In a lot of organizations, they use SAS as a statistical tactic. So this is the picture that we'll come back to from time to time so we can remember where we are. But as you can imagine, we're going to start at the top. We're going to look a little bit at the purpose of statistics, but we're really going to dig in this discussion into data concepts. So we want to get to know our data, right? And so we're going to start out with a very simple pile of data, or set of data. We're going to have a file, a data set called baseball player salaries. And that data set's going to have four fields, four variables, four pieces of data, four different kinds of data. And we're going to have player name, we're going to have the player's team, the name of the team, the player's position, like pitcher or outfield, and then we're going to have the player's salary. Now, as you can see in looking at those four fields, it's always useful every time you see a field in a data set to ask yourself if the data in that field is numeric or not numeric. And the reason is you cannot use statistical tools directly on not numeric data. You have to have numeric data to use mathematical formula, which is what statistics is. So, you know, we've got a field here called salary, and we can do some interesting things with salary. Doesn't mean we can't do something with, say, player position. Because later, when we get into inferential statistics, you may want to say which positions pay the best salaries. And so it would be a perfectly legitimate thing to do. And so later we'll learn how to take not numeric data, if we're interested in analyzing it, and turn it into sort of numeric data. So we'll talk about that in a bit. We're going to take a stroll through this file as we go along. We're going to analyze salary in particular, and we'll see what else happens. Okay, so major concepts of data. We really want to understand how to make sense out of data by using some very simple tools that statistics make available to us. And so those tools generally referred to as summary measures, descriptive measures, tools, and graphs. So we have a set of raw data. It's just raw. It might be 10,000 records or 1 million records or 25 records. And we want to extract meaning. Now, if it's only 25 records, sometimes you can extract meaning by just looking at the data with your eyeballs. And very often when students are given problems, if the data set is too small, students try to brute force their way through answering the questions just by eyeballing the data. But that's not going to be allowed or permitted. What we're going to really want to do is create graphs and charts and histograms and scatter plots and time series graphs, and you know what those are. And we're going to want to create and generate numerical summary measures, counts, percentages, averages, how does the data vary, measures of variability, and summary measures like totals and averages and counts, and so on. So we have to learn about these things in order to be able to do them, and that's what this lecture is all about. So data analysis in the real world, it's used to solve problems. There's 4 steps. Recognize that a problem needs to be solved, gather the data you need to understand and solve the problem, analyze the data, and act on the analysis. Right? So once you've analyzed the data, you get some output, you interpret what that means, and then you tell decision makers, here's the direction we should probably go based on what the data tells us. Okay, so that's the process. I've mentioned that before. Remember, we're going to start with like 3 and 4 and focus on that because we want to understand statistics. We're not going to really focus as much on research methods, which is 1 and 2. So on this slide, I forgot to change the colors, but I changed the background color on the slide. So a data set or a file includes all entities of interest, people or households or measures or whatever. And there's 3 typical populations, all potential voters in a presidential election. The word that you can't see here is a population, the target population. So the target population has everybody. So if I want to study students on the East Coast, then all students on the East Coast are in my population. You know, I haven't narrowed that, right? So that would mean elementary students, middle school students, high school students, college students, and so on. So that's my target population if I say all students on the East Coast. So I may want my target population to be more narrow, like all graduate students on the East Coast. So that's certainly a smaller number of people, right? And so just recognize that your target population is needs to be stated as clearly and concisely as possible. Usually the target population is still very large. So if I'm talking about all graduate students, even say in the state of Maryland or the state of Michigan, that's a lot of graduate students, right? There's hundreds and thousands and maybe tens of thousands. It's hard to say. So being very clear about your target population, being very specific about it helps you. A sample, which is the bottom bullet, is a subset of the target population. And why do we do samples? Because the target population is too big. I don't want to give out 40,000 surveys because I don't have the money and I can't afford 40,000 stamps to have them returned to me. I know we use the internet, but let's pretend. And therefore, I'd like a representative sample of all graduate students on the East Coast. And so sampling is really kind of key. And so we'll mention these terms. Remember, I've mentioned to you before that we're not going to actually collect the data and focus too much on sampling. But, you need to understand when you're looking at a pile of data, is it a sample of a target population? And there's some very good reasons for that. We'll get into the reasons in short order. You have to have good data, and good data means it has to meet certain criteria. But anyway, so target population and sample. Data set, variables and observations. Once you have your data, you have to put it into some system, some place, some holder. That's called a data set. It's a rectangular array of data with variables listed across as columns, and each row is one record, one observation. Statistically, simply called an observation. So if I get one survey back, it's one row in the table that's the answers to that survey, it's one observation. If I get 600 surveys back, my table is going to have 600 rows because I've gotten 600 surveys back. I have 600 observations. So I have 600 names, 600 player positions, 600 salaries, and so on. Now, I actually took out a couple of slides to make this lecture reasonably short. But if you get a record, an observation back, a survey or something, and one or two of the data items are missing, say salary and player positions back, you got the name of the team, you don't include that. It's incomplete data, and if it's incomplete data, you take that out of your set because that will throw off your analysis in a large way. So make sure that if you have incomplete data in an observation that you don't use that observation. Set it out. Variable are the different fields, and the observations are different rows. Okay, an example here of a questionnaire. The objectives identify the variables and the observations. As you can see, we have the persons numbered 1, 2, 3, 4, 5 down the left side. I generally don't do that, but some people like to see their things serial and numbered. You can see the ages in the next column. You can see these are all your fields or your variables. You have gender as a variable. You have state as a variable. The number of children is a variable. Salary is a variable. And their opinion, 1 to 5, is a variable. That's called the Likert scale, 1 to 5. Useful to us, but we'll have to talk about how to deal with that later. And then you can see that I've got one observation here of a male who's 35, lives in Minnesota, has one child, $65,400 in salary, and his opinion of whatever question was asked is a 5. And you can see another observation of a female in Texas, and so on. Variable names, when you make up the names for variables, make them so concise. You don't want a really long name for your field or your variable. And this slide here points out that in the first field there's something called an index of observations and numbers. Again, I don't always do that unless I have a reason. Okay, now we move into some very important concepts here. This is extremely important for you to understand that when you create or you are given a file and you start looking at the different variables, it's very important for you to understand the nature of the variable. Now, we kind of did this earlier. We said to ourselves, is the variable numeric or not numeric? And so that was a very useful thing to do. Well, now we're going to be a little more sophisticated about whether, when we look at a variable, whether it's numeric or not numeric. So we're going to look and see if the data is numeric, and if it's numeric, is it continuous? In other words, can it go on forever? Like a person's age can go on forever, right? But that 1 to 5 is something that has a 1, 2, 3, 4, 5 option and nothing else, and that's called discrete. So sometimes it's useful to note that the variable is either a continuous number or it's a discrete number. Cross-sectional means that the data was taken at a single point in time. If you gave out the surveys in May of 2015, or longitudinal says that the records represent data from this year and last year and the year before and so forth. And so you could have longitudinal or data over time data. And we're not going to do that too much. We're mostly going to deal with cross-sectional data. But I will get into, in the very last slide of this lecture, and future lectures, especially when we get into regression analysis and time series analysis. I have special lectures for longitudinal data, so you'll see those. So we're mostly going to deal with cross-sectional, which means that sort of a single point in time. If the data is not numeric, remember we had 3 fields, right? We had the name, the person's name, we had the person's team, and the person's position, right? That data is called categorical. And so, like the person's team, there's certain categories of teams. Let's imagine that there's 26 baseball teams. So that column, or the variable called team, would have 26 categories. Player positions, let's pretend like there's about 12 positions. Okay, we won't get into the details of baseball positions, particularly hitters and other special positions, bat boys, etc. And so if we assume that there's 12 positions in baseball, then the field that the variable that denotes has 12 categories. And so we'll consider that a data that's not numeric has ordinal or nominal data, and I'll get into that. So now you come to this concept, and I will say to you as a person trying to learn statistics, you have to memorize the levels of measurement, the types of data. You have to. There's just no way around it. And I remember my struggle trying to do this, and still today, I have to okay, let's remind myself again. Okay, now I started out by knowing the categories, there's 4 of them, as noir, which means in French dark. Noir, N-O-I-R. And that means nominal, ordinal, interval, and ratio. And so those are that's how I remember it with my little acronym. And so, so the first 2 categories, nominal and ordinal, are very special types of data. Nominal data is data that's simply not numeric. Okay, so if you have a variable that has male, female, M's and F's in it, if it has C for Caucasian, AA for African American, or whatever, it's nominal data. Now, we will be able to do statistics on nominal data, but we have to do some hoops. We have to jump through to do work on nominal data. Because you may very well want to know if there are differences between males and females, right, gender. So we have to know how to deal with nominal data. But collecting nominal data is an okay thing to do. You don't have to convert everything to numbers, at least when you're collecting the data. Ordinal data is generally not numerically meaningful. It's numeric, right? It's numbers, but it's not meaningful, right? Numbers. So nominal is data that's not numeric. With ordinal, interval, and ratio are numeric data. Now with ordinal, you have data, but it doesn't really mean anything by itself. So like if there's a class rank, or if there's a the finish in a race, or something like that. If you've got data, it's 1, 2, 3, 4, 5, 6, 7. but it doesn't really mean anything. Does 5 mean anything other than 1? Well, no, it's just that, you know, the fifth person finished or is behind the first person, but it's sort of like an artificial or a contrived type meaning. And so we often have data that are ordinal in nature and not very meaningful. The next thing is interval, and ratio are really the true numeric values. And so when you deal with interval data, which is going to be what most of your numbers are, it's numeric and it has equal units of measure, like an IQ score. IQ score is not the same as your rank. An IQ score, if I say a person has an IQ of 100, that's meaningful. Versus the class rank, someone is 7 doesn't mean anything other than that there are 6 in front of them and a bunch behind. But an IQ score of 100 has a specific meaning. It's a mark of intelligence. And there's some debate about a 1 to 5 scale. But I think what you'd find is a 1 to 5 scale is generally interval type data. And so you can find people that argue with me that it's ordinal data, but we're going to consider it as interval data if we give out 1 to 5 scores on the questionnaires. And then ratio data is, you know, your pure data. That's data that has a true 0, like your age. We all have a 0, right? Time has a true 0, and money has a true 0. There's no money, and then there's some money. And so the purest of all data is ratio. So you need to know when you look at a variable whether it's nominal, ordinal, interval, or ratio. And it's okay to have a little confusion about it, especially between ordinal and interval. We'll kind of crunch through a little bit of that. But we'll deal with those as we come to it. But knowing whether something is nominal and not numeric, or numeric, is really important. And we need to spend some time. Okay, so when we go through and we look at the baseball player salaries, we know that the categories, it's funny, it says baseball player salary, but the data is actually the other example that I gave. So forget the baseball player salary. Looking at the data below, which of the following are nominal data? Well, you can just look down here. You can see that age is numeric, right? So it's not nominal. Gender is nominal. State is nominal. Number of children is not nominal, right? Because it's got numbers in it. Salary is not nominal. And what about opinion? Opinion is not nominal. So you can sort of see as you go through this that you're looking for the nominal values, right? Gender, race, color, blue, green, red, city, Baltimore, Mount Pleasant, or whatever. Ordinal data. Numeric denotes order, but distance between the values is not meaningful. Class standing, professional golfer ranking, etc. Interval data. Numeric, equal units of measure. Likert scale, as I said. Temperature, because we have 2 different kinds of temperatures, Fahrenheit and Celsius, which kind of suggests that the absolute 0 is not really meaningful to it. Europeans like to measure in Celsius and we measure in Fahrenheit, so what the heck. Ratio, similar to the interval, but with absolute 0 point, age, time, distance, monetary data. So it's just more of a visual thing of what I just said. Okay, categorical data, nominal, ordinal are considered categorical. They have categories. Ordinal data is natural ordering of its possible values, but nominal is no natural ordering. Categorical variables can be coded numerically or left uncoded. So you can have either, in your data file, in your variable for gender, you could have M for male or F for female, or you can convert it to a 1 for male and a 2 for female. Now let me ask you this, what's the problem with using the 1 for a male and 2 for a female in a column of data where you just see the column of 1s and 2s? Well, the answer is that you have to know what a 1 stands for, whereas with an M and an F, it's a little bit more intuitively obvious. So my general recommendation is to code variables using a meaningful mnemonic, a meaningful abbreviation, rather than just converting everything to numbers, because you'll pay a harsh price later. When we want to do math, we're going to have to convert that M and F to a 1 and something else, 0 and 1. So we'll do that later. We can't run statistical procedures directly on numeric data. We have to make it be numeric. And so what we would do if we have an M and an F is we have a column variable called gender with M's and F's, and right next to it we create another column, and we call it gender dummy, or whatever. And in that column we would then, and we like to use zeros and ones when we use dummy variables, and there's a reason in statistical packages for that. So we generally would decide whether the male is 0 and the female is 1. And so we just, in this new column that we created, we go down and we code every male as a 0 and every female as a 1. And we do that, now we can do statistics on gender, and that's very important. That's what this slide says. For numerical data, numerical variables are discrete if they're numeric in nature, if they result from accounts, let's say number of children, or whatever. They're continuous, if they just go on. Height, weight, those are things that go from 0 up. I already mentioned cross-sectional, which is what we're going to use most of the time. And time series or longitudinal data is collected over time. We'll come back to longitudinal data much later. Descriptive measures for categorical variables. This is where we're going to begin to really get into some of the significant details of how to make sense out of the data we're looking at. So we've got a pile of data, and we want to make sense out of it. So that's what we're going to do. Now I'm going to pause this lecture here because, unfortunately, I have to upload these files to YouTube, and the smaller the file, the easier it is for me to upload. So I'm going to take a break right here and come back to this in part 2 of this quick lecture.